Right. Welcome everyone to our 9 o'clock briefing on oncoming deluge. Climate change heats up flood risk. This will be recorded and so you'll be able to watch it on YouTube after the show. For reporters who are online, reminder, you can put your questions into the Q&A box at any time. Please give your full name and your affiliation and tell us if you would like us to open your mic or you would like us to read your question for you. And with that, I'm going to turn it over to my panelists to introduce themselves. You're going to hear 3 presentations and then we'll go to Q&A. Thanks.
Hello, good morning. My name is Ruby Leung from the Pacific Northwest National Laboratory. Okay, so today I'm going to talk about a particular type of thunderstorms called mesoscale convective systems. And I'm going to particularly focus on their past and future changes. All right, so we call them mesoscale convective systems. I will just refer them as MCS. So MCS are a particular type of thunderstorms, and they generally have a pretty big size. In fact, they are the largest type of thunderstorms, generally with an area covering the size of a few hundreds to even a few thousand kilometers or miles. So they are very big. They generally produce a lot of heavy precipitation as well as strong winds. And therefore they are a major cause of flooding as well as wind damages. MCS, they form quite a lot over the tropical area, so they're ubiquitous over there. But even over the United States, particularly east of the Rocky Mountains, like in the central United States and eastern United States, they also form quite often, particularly during the warm season between April to August. So in the last few years, we have made some advances in methods to identify and track these type of thunderstorms called MCS. And because of that, we are able to quantify and understand whether these type of thunderstorms have changed in the past because of global warming. So we look at observation data in the past 35 years. What we found is that if we look at the precipitation produced by these thunderstorms, particularly looking at the heavy precipitation, like the upper 5 percentile of precipitation, we found that these thunderstorms over the US east of the Rocky Mountains have already been producing heavy precipitation more often during the 35 years. At the same time, when we look at the lifetime of these thunderstorms, they typically last much longer than these smaller individual convective storms. They last generally 10 to 20 hours. What we found is that over the last 35 years, these storms have also been lasting longer. So you see an increasing trend over there. Yeah. So because of these changes that we observed in the past, and then we further analyze why we are seeing these kind of changes, we see a contribution coming from global warming. And therefore, this study motivated us to look at how these type of thunderstorms may be changing in the future. So the general public and stakeholders, they generally like to think about extreme events and they remember them very well, because particularly for extreme events that cause a lot of damages with societal impacts. And they often would ask a question like, what should I do and how should I prepare for these type of extreme events if they were to happen again in the future? So because of this type of question, we wanted to really particularly select extreme events that had happened in the past with big impacts, and then we asked a very similar questions. So in this case, we selected 2 thunderstorm cases, and they are all belonging to these mesoscale convective systems, and they happened in the past. The first case study that we looked at is this flooding event that happened in May of 2015 over Texas, Oklahoma. So during that particular month, as you can see in this figure over here, there is a series of storms, an unusual number of storms, one after another, passing over Texas, Oklahoma, producing really heavy precipitation and therefore flooding. In some of the areas, such as shown over here, like in Dallas and Oklahoma City, they even exceeded like 200 to 300% above the normal amount of precipitation. So then the question question that we ask is essentially, how would this flooding event unfold in the future if it were to happen again, but under very different environmental conditions because of global warming. So with that, we look into this storm and we find that the sequence of thunderstorms that happen during that time period form in a very favorable and very strong weather pattern. And so if this weather pattern happen again in the future, but under global warming, there would be warmer temperature as well as more moisture in the atmosphere. So then the question is, how would these storms look like? And so we use a very high resolution model to simulate the storms as they were observed in the past. And we find that the model actually was able to really reproduce the storms as they were observed. And then we run the model again using conditions that correspond to the projection for the future, particularly with global warming. And what you can see is over here, I'm showing you the probability of precipitation at a range of rain rate, from low rain rate to very high rain rate. What you see comparing the blue and the red curve, the blue corresponding to the storms simulated as observed, and then the blue are the storms producing precipitation simulated for the future. What you see is a shift towards the heavier or more intense rain rate. And this is not too surprising because we know that under global warming with more moisture in the atmosphere, that would provide more energy for the storm to intensify and produce more precipitation. And so now we look at another storm. So this one happened in 2012 in June, and it also produced a lot of damages. And this is for a particular subset of storms belonging to mesoscale convective systems, MCS, but they are particularly called derecho. So these type of MCS storms, they produce not only heavy precipitation, but also very importantly, very strong winds. So in this particular case, you can see based on observation, these storms, this particular derecho storm swept across the eastern United States and leaving really a path of destruction with the strong winds knocking down power poles and also causing damages to transmission lines, etc. So there were quite a lot of damages associated with that. So again, we asked the question, like, how would this particular derecho look like or unfold in the future if it were to happen again under future global warming condition? So again, we use a very high resolution model that allow us to be able to simulate this type of storm that produce very strong winds. So here you can see our simulation of this particular storm as observed in the past, producing strong winds of the order of 20 to 30 meters per second, which correspond to roughly around 45 miles per hour. So these are really indeed very strong winds with a very long path as well as a wide swath, really producing a lot of destruction. So when we impose the conditions for the future and look at how the storm unfold, what we found is that opposite to the example that I show you, this storm actually under global warming scenario, in fact, becomes weaker. So as you can see, it does not produce as strong winds as the present day. So this is for the future and this is for the present day. So the winds are weaker, and also the lifetime of this storm also becomes weaker. So then the question is, why the storm behaves so differently under global warming compared to my previous example where the storm intensified? So what we know is that this storm did not happen under very strong favorable weather pattern condition. And therefore for this type of storm, what happened near the surface is really important. And a very robust signal under global warming is that not only there would be warmer temperature and generally more moisture in the air, but near the surface, climate models project that there would be drying near the surface. The relative humidity will actually decrease. And because of that, this is really contributing to why the storm becomes weaker in the future. But then we would also ask, like, but what about the lifetime? Why the lifetime becomes so much shorter such that the storm does not even pass through all the way to the mid-Atlantic region? So what we found is that the Great Lakes under global warming would be warmer temperature, so there would be more evaporation precipitation coming from the surface of the Great Lakes, and that the wind blows the moisture air downwind of the Great Lakes. And therefore, some smaller convective storms can form, and these smaller storms can consume all the energy ahead of the derecho, such that when the derecho pass through, there were already no more energy for the storm to be sustained, and therefore the lifetime of the derecho also becomes shorter. So these two examples tell us that it's really important for us to look at different types of environment for the different formation of the different storms, and the story can be actually quite complex. Although the story is complex, we generally understand that under favorable weather pattern, with global warming, increasing temperature and moisture, we would expect intensification of the storms. But for storms that do not are not supported by strong weather pattern, then near surface condition can be important, and then that could result in actually opposite response coming from the storms to global warming. So with that, thank you very much for your attention.
Good morning, everyone. Myself, Nanditha. I'm a PhD scholar from Indian Institute of Technology, Gandhinaga. Today, I would be talking about the catastrophic Pakistan floods in August 2022, its causes and implications. So, I would begin with summarizing the major findings that we observed. So Pakistan received extreme precipitation throughout the monsoon season, right from June, which lasted until August, and which saturated the soil conditions and which increased the chances of flooding in 2022. Also, we found this major rainfall spells that occurred towards the end of August is related to atmospheric rivers. So I would come to that later on. So also we found in the downstream reaches of Indus River Basin, right through the flood, which passes right through the flood extent, we observed very high stream flow, which exceeded 99.9% of climatology. Further, we found these conditions of multiple day extreme precipitation events would be increasing in a future warming scenarios. So to begin with, first we looked at the flood inundation in Pakistan. So as you can see from the inset figure, the major flooding occurred in the southern provinces. So blue color shows the flood inundation, which is overlaid over the population density. The darker shades indicate thicker population. So what made the 2022 flood very distinguishable is that it occurred on the southern provinces, which is thickly populated, increasing the damages and affecting more than 32 million people. You can also see the damages to crops in the green color in the flood inundation zone. Now, if you look at the precipitation that occurred during July and August, the left panel shows the climatology. The southern provinces have been an arid area with a lower average daily precipitation in July, August. However, in 2022, it far exceeded the normal precipitation amount or the climatology. So if you look at the bar plot in the downside, you can see red color is the climatology, and precipitation in August, right from 5th of August exceeded the climatology with major rainfall spells happening on 16th of August and 23rd August. And this to investigate what was the soil moisture conditions prior to these major rainfall spells, we looked at that, and you can see the green color, which shows that soil moisture was extremely anomalous due to the continuous precipitation Pakistan received right from June. And when the major rainfall spell occurred, it directly translated to flood event. Further, in an arid region like Pakistan, what simulated this much extreme precipitation or major rainfall spells? For that, we investigated the atmospheric characteristics connected to the two major rainfall storms of 16th August and 23rd August, and we found this is related to a feature called atmospheric rivers, which are narrow and elongated stretch of atmospheric system that carries moisture directly from the tropics and dump it over these tropics or the subtropics. So major atmospheric river coexisted with the major rainfall spells that occurred in towards the end of August in over the southern provinces in Pakistan. Further, to identify whether the major flooding was driven by the extreme precipitation or the glacial melt from the northern reaches. We looked at the stream flow pattern towards the downstream reaches of Indus River Basin. You can see the stretch from upper. We looked at the stream flow simulation at the upper basin, and we found the stream flow in 2022 isn't much deviation from the climatological mean. But however, if you look at the stream flow in the downstream range, which is Kotri, then you can see it is a higher value, which exceeded 99.9 percentile. So that implies the stations in between these reaches contributed much to the stream flow or the discharge. So we found that the standardized departure of discharge in these particular stations, station 1 to 4, far exceeded something like 300% from the climatological mean, which implies that major flow contribution is from the southern reaches rather than from the glacial melt contribution from the northern reaches. Further, we looked at how these kind of precipitation events of multiple duration would evolve in a warming scenario. So the red, So the red color here indicates a pessimistic scenario, and you can see the frequency of events would increase in a 30-year period from 1950 to 2070. If you can see from the observation, if it was 30 events in a 30-year period, that will become quadruple by 120 events. So finally, to conclude again, so we found that extreme precipitation persisted in Pakistan right from June and lasted until August, which saturated the soil moisture. And while the major rainfall storms occurred towards the end of August, it led to or converted directly into a flood event. Further, we found these rainfall spells that occurred towards the end of August is related to atmospheric river, which is a narrow, elongated moisture transport system that carries moisture right from the tropics to the subtropics. And further, we found that such events, so multiple day precipitation events, are projected to increase in a warming scenario, which is calling for major climate actions in South Asian countries. Thank you.
Hi, everyone. So can you hear me well? So this is Seongjin from Kumoh National Institute of Technology, joining virtually from South Korea. So in my talk, I'd like to show you what is happening in Eastern Asia, especially in South Korea this year in the context of urban flooding. So next slide, please. Okay, so we are seeing extreme flooding with an unprecedented scale in South Korea. In September, Typhoon Hinnamnor landed and passed through the southern region of South Korea. It was one of the most powerful storms in decades, causing a lot of damage, especially in Pohang, shown in upper right panel, a coastal city and home to one of the world's largest steel companies. Downpours of 13 inches in the morning caused flash flooding and casualties at an underground parking lot. Some researchers are saying this extraordinarily powerful typhoon was attributed to sea surface temperature warmer than usual, partly due to La Nina and climate change. So next slide, please. Okay, thank you. So if you watch its famous Oscar-winning film Parasite, you may remember the type of housing where the main character's family live. They are living in a semi-basement apartment, which is home for low-income families. So I don't want to be a spoiler here, but if I may add a little more details on the movie, a flash flood occurred in the semi-basement apartment, changed everything in the movie. Similar but real-world flash flooding unfolded in Seoul 1 month before Typhoon Hinnamnor, but in a more tragic way. Severe rainfall broke an 80-year-old historical record in some rainfall gauges, the frequency of daily rainfall was more than 100 a year. The map in the left panel made by Seoul Institute shows the density of semi-basement apartment. Unfortunately, several people drowned inside them during this event. Although heavy rainfall downpour nearly all over the southern Seoul, we observed the uneven impact of urban flooding with more significant damage in low-lying areas such as semi-basement buildings. In South Korea, as you know, more than 90% of people are living in urban areas. So after this extreme event, some people are recognizing urban flooding as one of the biggest social issues. So next slide, please. So I'd like to briefly introduce my research project just started several months ago as one of research efforts for urban flooding. So I think we can improve resilience and readiness for urban flooding and climate change with new techniques such as big data, virtual reality, modeling, and data fusion. So as you see in this figure, so when he's watching the urban street through his cell phone, although the street looks quite peaceful at this moment, but he can get more information about incoming risks such as urban flooding, urban heat island, and icy road in the near future or in an environment with climate change. That's the basic idea of what we are trying to do in this project. We know the technologies cannot solve all the issues with climate change, but I think these new techniques can improve public awareness and readiness for urban flooding and other climate-related issues. So next slide, please. Okay, so one of initial results of this project is virtual reality shown in the middle panel. So in this virtual reality, she is following her daily jogging course. But this virtual reality is not just virtual. It is based on high resolution remote sensing data shown in the lower right panel. So this centimeter-inch resolution data was used to reconstruct a flood-prone area in a coastal city, Busan, in this virtual world. We are also developing hyper-resolution flood maps in this catchment shown in the upper right corner and planning to include flood risk information from this model in the virtual world. Then one day in near future, as Mr. M shown in the lower left corner at home before heading out, we may improve our readiness for urban flooding using virtual and augmented reality techniques. So next slide, please. So that's all that I have. So I'd like to let you know this slide was put together by NOLAB members and researchers at Busan National University in this picture. Thank you for your attention.
Thank you so much, speakers. We're going to open the floor to Q&A, and we have quite a few online, so most of our questions will probably be online and one reporter in the room. So Becca, are we ready with questions?
Hi. Oh, sorry, do I have to turn this on? Is it on? Okay. Hi, I'm Barbara Moran from WBUR in Boston. And I was wondering, this is a question for the first speaker about the derecho. And I was wondering if you saw, or with the other storms, any change in where they're going instead of just the strength of them. Thanks.
Yeah, thank you for the question. So for that particular derecho, our simulation assumed that the similar initiation occur for this derecho, and therefore we do not see substantial changes in the path of the derecho, partly because even though it did not happen under a very strong weather pattern type of condition, it's still a very strong event, and therefore it's quite unlikely that that type of event in terms of the path will be significantly changed by global warming. And we more expect to see changes in the intensity, like how strong the winds might be and how much precipitation they produce, rather than the path. Yeah, thank you.
I have a general question for the panel. If you could speak a little bit to what,
Oh, were you able to hear? Yeah.
yes,
Okay, thank you.
you are good. For all of you, if you're seeing, like, in general, increasing intensity of these storms or changes in their patterns, how do you advise when you're asked by cities, how should I respond? How should I change my infrastructure? What will we need for the future? Do you have like thoughts on how we would prepare for these changes?
Okay, right, like these extreme events are anyway projected to increase in warming scenarios, and definitely preparation is required for mitigating this impact. So especially particularly if you are concerned about the South Asian countries or populated countries, so in the flood plains or flood prone areas, there are a lot of population, and mostly if we could figure out some zoning methodology or to identify, like to remove or migrate population in very exposed regions, that would reduce the exposure to flood events or any climate extreme. So understanding how much vulnerability or exposure is there in the current scenario, and to manage and bring about methodologies to reduce it. For instance, there are in case of flooding, we can also look for some structural measures and as well as non-structural measures. So structural measures, I think to some extent works pretty well in European countries, where you construct some levees and reservoirs, and which would guide flooding. But most of the time, if there is extreme events, we also see them getting affected. So non-structural measures in terms of early flood warning and proper conveying of these particular signals to the population, so that they could be moved, so that at least we can reduce the casualties. So in the case of Pakistan 2022 flooding, over 1,700 people have lost life and over 12,000 people are injured. So some form of evacuation before this particular event would have reduced these casualties. Thank you.
Yeah, I also want to answer this question a little bit further. So oftentimes we think about like, oh, it's probably easier to predict the average condition rather than the extremes, because after all, extremes do not happen very often, right? But in fact, under global warming, particularly if we are talking about changes in precipitation, it's rather difficult to predict the average changes, because there can be changes in like the storm in terms of the path and the jet stream location, etc. On the other hand, it's actually very robust features or signals coming from our projection into the future that extreme events will increase. And extreme events include the type of storms that we are talking about, as well as like heat waves and things like that. And that largely is because of the increase in the energy, right? So under global warming, with the warmer temperature, number one, that's a lot more energy. But another factor which we often overlook is that with warmer temperature is also generally more moisture, and moisture itself is also a very important form of energy. And therefore, with a larger amount of energy, we would generally expect extreme events to be increasing. And this type of information is actually rather available. For example, over the United States, we are currently working on the National Climate Assessment, which is provided every 4 to 5 years. And so the 5th National Climate Assessment also has very strong messages and information regarding changes in extreme events, and the report will be released next year. So a lot of information coming from literature such as National Climate Assessment, as well as direct information coming from climate models, projections. We actually have these data all collected in centralized location, accessible by anyone, including the general public. And these are all very useful resources to think about how we might respond in the future.
So if I add a little more. So as previous panel mentioned, we need structural and non-structural measures to improve readiness for urban flooding, in my view. So as structural measures, cities like Seoul are planning to construct very large multiple rainwater tunnels to drain stormwater quickly from urban area. However, due to some financial and priority issues, structural measures may not enough to prevent all the urban floodings. If there would be no extreme flooding in the next few years in a row, then people will forget all the risks in urban area, and there will be definitely budget cut. So some non-structural measures such as flood warning systems, information and communication systems using some metaverse and other techniques are also useful to improve readiness for this urban flooding. Okay, thank you.
And we have a question for Ruby. Your modeling of these storms was applied to the US specifically. Could you speak to their applicability to other land masses, other storm systems, and other continents?
Yes, definitely. Number one, as I mentioned before, this type of MCS or mesoscale convective system, really the largest type of thunderstorm, they happen in many regions, particularly over the tropics, in regions such as like monsoon area, in Asia, in South America, in Africa. And it's important to really understand how these storms will be changing in the future. And the type of modeling techniques that we use essentially is to use a climate model, almost in a sense of like a weather model. And we can run these models now at very high resolution, partly because of these bigger supercomputers that are available. So with this kind of technique, so because the models themselves are built based on the first principle, mostly, right, based on the equation and things like that, and they are applicable, doesn't matter whether you applied it over the US or in any region.
We have a question for Nanditha. The atmospheric river and flooding occurred in an arid region. If a similar event were to occur in a more moist region, would the flooding be more intense, more extreme?
Thank you for the question. So in this study, like what we have monitored, whether this particular extreme event is connected to atmospheric rivers or not. So yeah, like it's not necessary that the condition, whether it is arid or humid, would increase. It's not based on the climatic condition of the region where this atmospheric river is debouching, but it depends upon how much moisture it carries. So it doesn't matter whether it's happening or occurring on a humid region or arid region. If a particular system develops and it has a high moisture carrying capacity, if which is estimated based on the total water vapor column from the low pressure to high pressure, if that intensity is very higher, probably it could cause high precipitation, provided other condition like a low pressure system also develops over a particular region. So it's not necessarily based on the particular climatic condition. That's how I understand it. Yeah, thank you.
I think we have no further questions online. And so I'd like to thank our panelists. This will be the end of this event. This event has been recorded and will be available on AGU's YouTube channel in about an hour after this event. We'll also post that to the Press Information Exchange for reporters along with their slides. And we're always available to connect you with these speakers. Reach out to us at news@agu.org. Our next event is at 10 a.m. It will be about Juno. We hope to see you there. Thank you all for coming.
Thank you.
Thank you.